Hello students, welcome back you all. This is Dinesh Singh Rautela. Today I am going to discuss about resistance. Dear students, we have already discussed about current, charges. So now today we will discuss about resistance. Dear student, resistance is an electrical appliance which oppose the flow of currents. So dear students, the property of conductor due to which it opposes the flow of current through it is called resistance. Resistance is represented by capital R and symbol of the resistance is this. And unit of resistance is ohm. You have to learn what is the unit of resistance. Unit of resistance is ohm. So dear students, as we are discussing, resistance is an electrical appliance which can oppose the flow of currents, and we can arrange resistance in two ways. First one is in series and in parallel. Resistance can be combined in two different ways. First one is series resistance. Dear students, you have to learn and you have to understand how two or more than two resistances can be connected in series and in parallel. First one is in series. Dear students, when two or more than two resistances connected end to end, or you can easily understand when resistors are connected in a same path of electric circuit. When two or more than two resistors are connected in a same electrical path, then the resistors are in series. This is the first examples of resistances. You can understand very easily. In this path, suppose there are 2 points A and B. According to our definitions, when two or more than two resistances are connected in a same path, so R1 and R2 are connected in same path. That is why R1 and R2 are in series. And second is this, again, when two or more than two resistors are connected in a same path, same electrical path. So here again, from A to B, three resistors are connected, and here is only one single path. R1, R2, R3 are in a single path. There is no different path and no distributed current is there. That is why this is also in series. So you have to remember very easily with the help of this definitions. When two or more than two resistors are connected in a same path of electric current, then all the resistors are said to be in series. Second one, my dear students, again listen carefully and try to understand what is the meaning of parallel resistors. What is the meaning of parallel combination of resistors? When two or more than two resistors are connected between these same 2 points, and you can easily understand with the help of other definition when two or more than two resistors are connected in distributed path of current. Here suppose that this is point A and this is second point B, and we want to know how resistors are arranged in this path, because both the resistors are connected in distributed path of current. This is the starting path of current. Here current is distributing from this point and this point again in two different directions. Here two resistors are arranged in distributed path of currents. That is why these resistors are said to be in parallel combination. When two or more than two resistors are connected in distributed path of current or different path of current, then all the resistors are said to be in parallel combination. Again, second examples of resistors. Here current is distributing from this point. In this case, these two resistors are in same path of the electric circuit. That is why these resistors R1 and R2 are in series, and R1 and R2 are parallel to the R3, because different current flowing in R3 and combination of R1 and R2. So dear students, we can conclude. First, we can derive or we can draw next diagram of this resistors. R1 and R2 are in series. The combined of these resistors are this and R3 is here. Suppose R1 and R2 are in series and equivalent of these are as R, and this is R3. Again, now we have next diagram of this. So here we can conclude that R and R3 are in parallel because R and R3 are connected in distributed path of current. Here current is distributing from this point. So with the help of this definition, you can easily conclude when two or more than resistors are connected in distributed path of current, then all the resistors are said to be in parallel. And when two or more than two resistors are connected in same path of electric current, here is same path and here is distributed path. When resistors are connected in same path of the electric circuit, then resistors are in series, and when connected in distributed path of electric current or circuit, then in parallel. Now dear students, listen and look carefully. Now we'll take some examples how can we calculate combined resistors in series and in parallel. Here students, in case of in series, formula to calculate equivalent resistance, R is equal to R1 plus R2. You have to learn with the help of this. Series is starting with S and sum is also S. So when resistors are in series, then we can sum all the resistors to calculate equivalent resistance. And for parallel, formula is 1 upon R is equal to 1 upon R1 plus R2 plus R3. Let us take one example. Now we have two resistors, 2 and 4. Calculate equivalent resistance. Suppose you have to calculate equivalent resistance. First we will decide these resistors are in series or in parallel. Here resistors are in the same path of the electric circuit. Resistors are in same path of the electric circuit. That is why 2 and 4 are in series. We will take formula of series combination. Formula of series combination R is equal to R1 plus R2. So here R is equal to 6 ohm. Next example, again this is the example of resistors. Here 2 ohm, 4 ohm and 6 ohm are in the same path of the electric circuit. Here 2 ohm, 4 ohm, 6 ohm are in same path of the electric circuit. That is why all the resistors are in series. Because all the resistors are connected in the same path, means not in distributed path of electric current. Current is flowing in same path. That is why all the resistors are in series. And to calculating equivalent resistance, we know that when resistors are in series, R is equal to R1 plus R2 plus R3. That is equal to 12 ohm. Now in the case of parallel combination, dear students, we have already discussed when two or more than two resistors are connected in different part of the electric circuits, then the resistors are in parallel. Here 2 ohm and 2 ohm are connected in distributed path of the current. Current is distributing from this point. Few currents is going upward direction and few is downward direction. That is why 2 and 2 ohm are in parallel. To calculate equivalent resistance, we have formula of parallel resistors 1 upon R is equal to 1 upon R1 plus 1 upon R2. That is equal to 1 upon R is equal to 1 upon 2 plus 1 upon 2. That is equal to 2 upon 2 and 1 ohm. So equivalent resistance of both these two resistors in parallel combination is 1 ohm. Next, again this is the diagram. How can we solve this numericals? Calculate equivalent resistance. Here P and Q are in the same path of the electric circuit, but current is distributing from this point. Few currents going downwards and few is upwards. Which currents going in upward direction? And now P and Q are in the same path. That is why P and Q are in series and equivalent of these two with R is parallel. First we will calculate P and Q. P and Q as in series. That is why R is equal to P plus Q. Because formula of series combination is R is equal to R1 plus R2. Now 2 ohm and 2 ohm working as a equivalent 4 ohm resistor. Now 4 ohm and 2 ohm are again in distributed path. That is why both these resistors are in parallel. Now we will write parallel combination formula 1 upon R is equal to 1 upon R1 plus 1 upon R2. That is equal to 1 upon 4 plus 1 upon 2. That is equal to 3 upon 4. Next reciprocal of this 4 upon 3. That is equal to 1.33 ohm. Dear students, you have to revise and solve numericals related to series and parallel combination at your home regularly. You can solve all the numericals very easily. Stay at home and be happy. Thank you.